Hi, everybody. So it is 9 a.m. And in the program it says we're supposed to have a speech for 30 minutes. We're not going to have a speech for 30 minutes. Sit down, like take your time, enjoy the fresh air, and we'll have like the proper like introducing speech for the conference in maybe like 10 or 15 minutes. So take your time. Thank you. LAC2025. You're lucky because we already had an opening ceremony for the gyms on Monday with all the people from the university coming and giving a speech, which actually took more than 30 minutes. So because that has already been done, it means that you don't get to listen to them, which maybe is better, And so anyway, welcome to Lyon and welcome to Linux Audio Conference. Stefan and I are the organizers of the conference. So. We just wanted to give you some information about how this event is going to work and just highlight some important things in the program. So first, for those of you who are at the banquet last night, thanks for being there. We had a little bit of drama, as some of you might have noted, but in the end, it worked out. We hope you had fun there. So just to give you an overview of the program. So there's going to be a sound installation. Which is going to be on the second floor, where the coffee is. So there is one thing that's somewhat important. So we're here in a library, and there is a hall, and they don't like when people talk in the hall because the library, it's poor design, basically. The hall is directly connected to the library. So basically, they asked us to do the coffee breaks in a different room upstairs. That's why you have to walk up to the second floor to get your coffee in a room where it's like 35 degrees Celsius. So if you just want to get your coffee there and walk down the stairs and go outside or come back to the theater, that's okay. There's air conditioning here for now. Hopefully it's going to be like that until the end of the event. But yes, so coffee breaks will be upstairs on the second floor. If you don't want to stay there because it's too hot, feel free to go somewhere else. But please don't stay in the hall. Okay, that's kind of important. So the sound installation is going to be there on the second floor. So that has already been done. Okay, this is the welcome speech. So we have a bunch of sessions throughout LAC. There is no parallel session, so everything happens one after the other. We're not multi-threading. We're yet. Yeah, we're having one keynote speaker who's going to be Michel Buffat. Michel Buffat is going to talk about web audio technology in general, and he's somewhere in the room, like he's hiding in the back. So he'll give the keynote speech today, actually. We have lunches. So for those of you who got the lunch option on time, sorry if you didn't. But for those of you who got the lunch option on time, you should have lunch tickets as part of your kit. And they're in French. And there is one per day. Now you're probably like, oh, I only got two. That's normal because on Saturday, the dining hall is closed. So we'll have lunch boxes delivered here for those of you who got the lunch option, okay? So for lunches today and tomorrow, we'll walk together to the dining hall, which is less than a 5 minutes walk from here. It's actually closed. It's going to be hot. Be aware that it's very hot in the dining hall. It's very, very, very hot. So just so you know, I'm preparing you psychologically, but I think you're getting used to it, right? So we're gonna have lunches there. They'll have vegetarian, vegan options. They serve food to students. In general. So they have different options. Then in the evenings, we're gonna have concerts, and the concerts will all take place at the Ashtray Theater. There's a link in the program on the website. If you click on it, it's a link to Google Maps that tells you where Ashtray is on campus. It's about 10 minutes away from here, so you have to walk a little bit more to get there. And so the concert of tonight will take place there, and the concert of tomorrow night will take place there as well. Be aware that there is no air conditioning in there. So it is hot. Like so, so if you don't like heat, just yeah, I don't know, maybe do something, or but like yeah, it is hot. We had concerts for the gym there, and it was pretty rough. So so like just warning you a little bit about that. You know, like in France right now, there's a lot of push everywhere for removing air conditioning because it's bad for the environment, and so so you know, like there are very few places on campus with air conditioning, and so we're lucky to be here now, and but unfortunately there is no concert hall with air conditioning because they don't want that. So but that's the way it is. Anyway, so that's for today and tomorrow. Then on Saturday, the concert will take place at a different location, which is called Le Sucre. And Le Sucre is literally on the other side of the city. Okay, so so it's not here. It's not on campus. It's a proper like concert venue / nightclub / rooftop. It's very nice. It's in an area of the city which is called Confluence. And you can go there from here taking the tramway. It's a long ride. It's probably an hour away, but tramway. So it's really like on the other side of the city. And so you're all invited to come. There is a small detail. So I don't know if people here registered late, but I sent a message to those of you who registered like a week ago or something like this with a Google form. Sorry, we're using a lot of Google tools. I'm sorry about that, but it's just for the sake of time, because we're pretty busy, you know, like, you know, and just anyway, we sent you a Google form to fill out. If you want to go to that specific concert, because this concert has a fee normally, but for you guys, there's no fee. So in order to know which of you want to go to the concert, you have to fill out the Google form, and then you don't pay the fee. Okay, and you should do this by who didn't get the form. Okay. So maybe I'll send it again this morning. Okay, just to everyone again. So sorry for those of you who already got it. So I'll send the form again. Fill out the form if you want to go to the concert on Saturday evening, and then you can go to the concert for free. Okay. One more details for the concert tonight and the concert tomorrow. You should get a ticket. It's free, but you have to get it online, okay? I sent an email about that. Maybe you didn't read it. So I'll send an email again with all this information, so the Google form and the links for you to get your ticket for tonight's concert or tomorrow's concert. You can probably also get the ticket directly at the venue. That's possible, you know, like, but you know, in case 200 more people show up, which is probably unlikely, but in case more people show up, if you want to secure your tickets, you should definitely get it in advance. So yeah, I just want to say that this event is possible thanks to a bunch of partners, and so so the main partners for this event are INRIA. INRIA is the French National Institute for Computer Science, basically. So that's what you have on your name tags. INSA is the institution that's hosting the event. Okay, so so currently you're on INSA's campus, and so this is an INSA theater, and so they also like sponsored the event. Then finally there is GRAM, which is represented here by Stéphane, and GRAM is basically like, without GRAM this would really not be possible. Like GRAM is taking care of the concerts, the technical sides, you know, and providing like people and management, you know, and so yeah, it's very important that GRAM is involved in this, and so and GRAM is basically like, for those of you who don't know GRAM, well, maybe actually Stéphane, you can say a word about GRAM.
GRAM is the National Center for Music Creation in France, so we have several of this kind in France, and as you know, we are doing research in computer science, music, and this kind of thing. We are also doing music production and transmission for different kind of public. And the link with Linux Audio community, we did that like more than 20 years ago. Exactly 20 years ago, I was presenting Jack2 in Karlsruhe at ZKM at that time. I guess I had my Macintosh computer, and the first version was only working on, the Jack2 version was only working on macOS, and I'm still there, so probably Linux guys are not too harsh. And then we had the Linux version and the Windows version. So we had this connection with the LAC community at that time with Jan, and it was a nice place to meet people doing real stuff and programming, and it was for us a good different kind of conference that we have with more academic-like conference. So GRAM is also really still working in this kind of connection.
Well, and now I think it's important to point out that Jack2 doesn't work very well on Mac computers. Not to say and that works very well on Linux computers. So that's. Anyway, I think that's probably all. So because the event is live stream, we're going to try to stick to the schedule, which means that the session has to start at 9:30. We're going to be very strict with timing. Okay, so yeah, I'm just double checking that it's the same as for the previous conference, because, but yeah, so you know, like your presentations should be like around 20 minutes, and then there is like an extra 8 minutes for questions and 2 minutes for changing, you know, and it's good if we stick to the schedule, because the canteen is pretty strict, a little bit like the guys last night. So if we don't. If we don't show up there on time, yeah, then we're not going to eat. So it's good if we can eat. Anyway, any questions? Yeah, of course. So it's not free per se, but I sent an email. I can put that in the email again. Basically, there is a guest Wi-Fi. But to access the guest Wi-Fi, you need to provide your name and your email address. And you have to do it in advance, and then they send you a login number and like password, which is individualized. And so it means that in order to get access to the internet, you need the internet. And unfortunately, there's so I already registered a couple of people this morning. The problem is that you can only register one email address at a time. So I already used all my email addresses, and so yeah. Worst case scenario, maybe we can because Graham brought the. So if you don't have the internet on your phone or something like this, maybe one thing that we can do is that, like, temporarily we can set up a 4G hotspot just so that you have the time to get to the link. But it's a 4G hotspot, so there is a limited amount of data, so we can't use it for the whole conference. So would that work? Do you want to do that? Yeah. Okay. So. All right, we'll set up the hotspot for like an hour. Okay, the name of it is Graham.
Yes.
And the
for you, je pense.
Yeah, the
the same, still the same.
Yeah, the yeah, that's the password. The name of the that's the password. The name of the network is Graham. It's probably not active yet. Okay, so we're gonna activate it for an hour. You should only use it to get your password, okay? And then you should connect to INSA Invité, which is the network you should use for the rest of the conference. And I'll send an email to everyone with all these informations again, so the link and the tickets for the concerts and everything. And so this time, read it. Yeah. Any other questions? No? Okay, great. So we're going to take a break for 7 minutes, and well, actually 8 minutes. And then we can start with the first session, which is going to be chaired by Jan. Nice. Okay. Thank you, and enjoy the conference.
I think we can start. So first of all, I would say that I'm very happy. It's so nice to see you all here in Lyon. Well, as Stéphane said, we have a special attachment, can you say that, to the Linux Audio Conference. So welcome again here in Lyon. And we will start with Florent Berthaud. Florent is presenting a Libre software framework for extended reality musical instrument and immersive sonic installations. Florent.
Hi. Okay. Hi, everyone, and thank you for coming, and thank the organizers for the whole event, Jim and LAC and everything. Yes, I'm Florent Berthaud. I'm an associate professor at the University of Lille, and I'm going to present a framework that we've been developing for our research projects and collaboration with artists. So we work a lot on extended reality and musical expression. Because this type of interfaces offer new possibilities, opportunities for musical expression. So this, of course, is not new. It started in the early 90s, and over the time we've had different types of visual displays, different types of interaction devices, and so on. And now we have the chance to have a lot more affordable devices, hand-mounted displays, mixed reality, virtual reality displays, and so on. So in our team, and over the years, we've been developing different types of interfaces, which started with cave-based instruments, like the first one in 2010, and then augmented reality displays for visual augmentations for the audience of electronic music performances. Then we've been performing with these instruments in different situations, as you can see here. We've also developed new mixed reality displays using, for example, optical combiners or semi-transparent mirrors and projectors. We've been using augmented reality to augment physical controllers, MIDI controllers, to help the musicians appropriate visual feedback on their instruments. And more recently, we've been looking at spatial augmented reality displays for musical expression. So basically, it's projecting virtual content in the physical space that the musicians can reveal either using their bodies, like this, using tangible objects, or using acoustic instruments. In this case, it's a couple of acoustic guitars with actuators, but also drums and trumpets, and musicians can use virtual objects that are placed around the instrument to sort of like control the actuators, so trigger notes on the strings and so on. And with the new accessibility of mixed reality headsets and the quality of mixed reality headsets, we've been developing a lot more applications using these. So for example, I'll go back to them at some point to illustrate how we use the framework to design them. But 3D musical drawing applications and mixed reality collaborative systems. So to do all these projects, at first we started with like low-level C++ programming for both audio and visual rendering. But now we have a number of different tools for designing these instruments. We have systems that integrate sound synthesis in 3D engines, like Trinity or UPD and so on. We have systems to communicate between 3D engines where you design the visual interfaces and audio software. We have web-based systems as well, which combine the audio rendering and visual rendering. And we have also a system in which you can do patching directly in XRs, for example, PDXR, where you can import your PD patches and then do the patching in XR directly. The problem we had with this is that like some of them are at least partially non-free software, with some that are problematic. For example, Unity recently had some massive issues like changing the license, or for example at INRIA I know that a lot of colleagues had issues with Unity because they sort of decided at some point that INRIA was using them in a commercial way, so it would mean that it would change the license, which is a big problem. Also, some of them are really are not that frugal in a way. For example, Unreal or Unity, which makes a problem if you want students to develop the instruments on their laptops, for example. And some of the systems only provide like limited audio or 3D interaction programming, whereas we need the two to be able to design new instruments, new interfaces. So our requirements for the framework that we've been developing was to be able to design new 3D interaction techniques, new visualization techniques, to be able to display on a variety of devices. We needed to be either low latency, so using jack on a computer, or to be able to embed the audio and render the audio from headsets, for example. We wanted to have like a fast and flexible workflow because depending on the project, we have different constraints in terms of how we develop the instruments. We wanted it to be lightweight, as I said. If we want like student projects, if they have their laptop, they usually can't, for example, open Unreal on their laptop because it's like way too heavy. And we need it to be free and open source. So for this framework, we picked two software that we combine. So the first is Godot. So Godot is an equivalent to Unity and Unreal, but way smaller, fully open source. It basically combines visual scene graphs editing and programming that you can do either in their scripting language, which is GDScript, or in C++, which is quite nice. It allows you to get gestural input, controllers, trackers through OpenXR integration. OpenXR is like the standard for access to mixed reality, virtual reality devices. It also gives you, by the same mechanism, access to a lot of different displays, visual displays, head-mounted displays, mobile displays, stereoscopic screens, and so on. Because it's a game engine, you have access to like very fine advanced rendering and 3D interactions. And also, what's interesting for us in terms of design is that you have access to live editing of the scenes while the application is running, and part of live scripting as well, which is quite useful. And on the synthesis side, but that's because I've been using PD for a long time, which is pure data, that you all know, so I'm not going to go into much detail for that. So the interest of this combination is that both are free and open source, and both allow for fast prototyping, which is really useful in our case when we develop all these instruments. So the framework is composed of two parts. So the first part is GDPD, and the second part is IVME Builder. So GDPD is a set of abstractions for pure data and nodes for Godot. And basically, the idea is that, as you can see here, it sort of allows you to, in a transparent manner, use send-receive messages from Godot to pure data. And the whole idea behind GDPD is that you can either do that in a distributed manner, in which case when you do send-receive, it's sent to the other software using Open Sound Control, or you can do it by embedding the PD patches directly into Godot. So using libpd, we can, in a transparent manner, change from, okay, I'm sending the OSM message to pure data, which is running on the laptop, to I'm sending the OSM messages to the patch, which is running in libpd, for example, in the headset directly. So during the design process, you can switch between the two, which is quite efficient in our opinion. And on top of that, we've built IVME Builder. So GDPD can be used for any application, any audiovisual application. IVME Builder builds upon GDPD, and it brings a lot of useful systems for creating 3D instruments. So we've had like nodes, scenes, properties that we can put inside the scene graph of Godot. It also facilitates the setup of extended reality displays and networking. It integrates a couple of 3D interaction techniques that we found useful for musical expression. So how does that work? So GDPD is both a Godot add-on, which is programmed in C++ and combines liblo for open sound control messaging, libpd for running the PD patches, RT audio to have access to real-time audio, jack, core audio, and so on, and the Godot audio stream player so that we can integrate the sound and play it directly through Godot, for example, on headsets. It's a lot easier to do it that way. It extends a node class from Godot. And on the PD side, we have PD abstractions, which sort of mimic the components that we have on the Godot side. So we have GDPD object, which by default is going to discover where the Godot application is running and connect to it and send messages. And then we have equivalent of send and receive from pure data, but GDPD send, GDPD receive. And what is really interesting is that we have 3 modes for combining the two. So we have which we call the PD mode. So it's either an OSC mode, in which case the system assumes that PD is running like separately from Godot, and then all the messages are being sent through OSC. We have the audio mode, in which case the patches are run directly in the Godot binary using libpd, and it's output through the Godot sound system. And we have audio RT, in which case, basically, we embed libpd and we use RT audio. For example, in our case, most of the time it's to go through Jack to have access to real-time audio and be able to integrate input, outputs, and so on. And this system can be used in 2D or 3D applications, so it's not for immersive instruments per se. And on top of that, we have IVMI Builder. So IVMI Builder builds on top of GDPD. As you can see, there's a IVMI scene node with some configurations in which you can set the PD mode, you can set the address of the system, you can set if you want to use OpenXR, like have access to HMD or not, if you want to use pass-through to be able to see the physical space when you use a mixed reality headset. You can configure the network to have access to set up a client-server architecture and have multiple instruments connected for collaborative instruments. It also integrates some 3D interactions that we've developed over the years and some from the 3D interaction literature, I would say, so navigation techniques, selection manipulation techniques, and some controls that we've developed, for example, dedicated widgets for musical expression. It uses OpenXR for input and rendering, which means that you can access headsets that run using SteamVR, headsets on Android, and you can also use the Monado. It's a free and open source version of runtime of OpenXR, which gives you access to a lot of headsets and also stereoscopic screens, scaves, and so on. So these are, oh, was a bit too fast, sorry. So I'm going to show you a couple of example instruments, and then I'm going to describe how we design each of them, and then go into more detail on one of them. So these are 4 instruments, some of which have been published, presented, some of which are ongoing, I'd say. Well, you probably see the difference depending on the quality of the video. So yeah, this first one is the work by a PhD student in our team, Esther Gruy. This one is work from another PhD student in our team, Pierre Cureau. So the first one was 3D drawing application. This one is a collaborative instrument in which you can decouple the points of view in VR in a virtual and physical space, which is why you see like a small avatar of the musician here with a different scale. Like the idea is to be able to change scale on the virtual instrument so that you can play with different interaction techniques. So this one is the ongoing one. And this one is an immersive installation that we created with an artist and we presented at IEEE VR earlier this year. Okay, so these were the 4 examples. So the first one is for a single user, and basically the user is using a mixed reality, like a MetaQuest 3 headset. And in this case, what we're doing is that we're rendering the audio on the laptop. So basically, in this case, we're in the mode where the Godot application communicates with PD using open sound control. We did that because in this case, we need like real-time input and output for the device that Esther made. And basically, it's sort of like disassembled speaker to sort of recreate that you recreate by like placing a stylus with a magnet on the tip of the stylus close to the speaker. And basically, all the like part of the sound synthesis is done, or the sound interaction is done in the physical space. So we needed real-time input-output. So we have the device, the laptop, which runs PD and uses jack, which communicates with the HMD using open sound control. The second one is Grainy Cloud by Pierrick Rowe, and we have multiple HMDs, but the sound is centralized. So all the Mixtuality headsets communicate with the server, and that the server communicates with the PD patch. Again, it's mostly because the sound is going to be the same, shared by everyone. So in this case, we needed a configuration where it's all external in terms of sound rendering. The third one is an ongoing project, and it combines Godot and Pure Data with an external software which we call Reveal, which is a spatial augmented reality software, which we're trying to integrate in Godot right now. And the last one, which is the installation that you saw. In this case, the audio is rendered for each participant of the Mixtuality installation directly in the headset. And I'm going to go into more detail for this one to show you what our framework allows in terms of design process. So basically, the installation is a Mixtuality sonic exploration of a virtual building. So you saw like there's a virtual building and inside a physical building. So it can be a church, but it can be anything. It's collaborative, and you have virtual sound sources placed in the virtual building. And the virtual building is going to expand, like change geometry, change scale, move, either automatically or you can do it. You can manipulate it at some point in the installation using a world in miniature metaphor. So in this case, we needed to render the audio directly on headsets because it's spatialized for each of the participants in the installation. So we have like binaural rendering, sound attenuation, and so on, and some amount of reverb that is being controlled using audio ray tracing, or sparse audio ray tracing. And in this case, what was interesting is that we could use the framework in the design process in 3 different steps. So we started with like a simple architecture with everything running on the same laptop, just to be able to make sure that the properties on both sides in Godot and Pure Data were working correctly, that the sound synthesis was correct on the laptop, and we were using headphones just to be able to see, okay, if I move the sound source, it's going to move correctly with the binaural synthesis, binaural rendering. In a second step, we moved to, okay, now we're going to use the hand-mounted display, the XR Mixtuality hand-mounted display, running a Godot client, and then on the laptop, we'll have the server. But we want to be able to edit the Pure Data patch while we're running the system on the headset, to be able to make adjustments, fine adjustments, change the volumes, change the sound sources, and so on. So it means that we can use GDPD in the OSC mode and have the HMD send OSC messages and change the patch while everything is running. And in this case, we were using headphones, wireless headphones, so that we could move around to test the system. And finally, to be able to deploy the application, we moved to the audio mode, not the RT, like not the real-time audio mode, but the audio mode in GDPD, to be able to run directly the audio on each of the headsets. So for us, it's really interesting to be able to change from one mode to the other, to be able to design different aspects of the system over time, and we found it quite efficient, actually. And that's it. So what we found is that this framework facilitated a lot of the steps that we had before, and which took a lot of time in designing new instruments. That means that we can spend more time thinking about interaction, about sound synthesis, and not so much about the architecture and how we combine the different components, combine the visual rendering and the audio rendering and so on. But there's still a lot of limitations in the system. So for example, when designing collaborative applications, for now it's not that simple because a lot of maybe Michel will relate to that, but a lot of connecting different different participants to the system, to the server, is still a bit, you need to do it manually, so it's a bit cumbersome maybe. The live patch editing that I showed here, so for example, changing like having the patch running on the headset, and sometimes you still need to make adjustments to the patch and then re-upload it to the headset. For now, it's not that efficient, so you need to restart the Godot application and re-export it to the headset, which is quite slow. So maybe some mechanisms to be able to send the updated PD patch directly to the headset would be quite useful. And there's a lot of other limitations that you can find in the paper. So the future work for this is that first, the documentation is really, really too light. I mean, as often. So that's something we really need to work on because it's being used by a lot of students and by artists also. So, and also we've integrated a lot of like existing interaction techniques, so it needs to be like easy to set up and access. We want to develop more of these interaction techniques, and what we do usually is that every time there's a new project, a new experiment, we try to integrate the result in the framework. So, like 3D drawing, the collaborative, or in this case, it was sort of like a concatenative synthesis application for the collaborative instrument. So we're putting all this in the framework, and also we want to enrich this IVME ecosystem. So we have GDPD and IVME Builder, but in 3D interaction, there's a lot of other things you want to access. So for example, there's a standard for input devices in a virtual reality, which is called VRPN, which gives you access to a lot of different 3D tracking systems, which would be nice to integrate in Godot. Access to depth cameras, access to the cast from the headsets to be able to display that during performances. Change it access to WebXR also would be something interesting, because we've seen with Michel's presentation that there's a lot of application, a lot of ease to actually distribute the systems, which is nice. And on the audio side, there's a lot to do as well. So for now, the specialization, so Godot has some amount of specialization, but it's quite limited. So for now, we do a lot of things in PD, but there may be other ways to do that. In terms of live editing or live coding things, integrating FOST in addition to PD would be something really nice, because we would be able to access different types of synthesis, and it probably would be more efficient in a lot of cases. And like inspired by the presentation on web audio modules, I think it's something that would be interesting for us as well, to be able to have access to a large database of plugins that already exist and be able to integrate them quite easily in our system. Yeah, so that's it for me. Thanks very much, and if you have any questions.
Thank you, Florent. So it was a perfect timing, exactly the number of minutes that Romain recommended.
It was perfectly planned.
Impressive. So we have questions. Yes.
Hey, sorry, I missed it maybe, but what hardware did you use for the headsets?
What, sorry?
Hardware.
Oh, it depends. So in the last ones, it was the MetaQuest 3. Yeah.
So standard off the shelf, like.
Yeah. But in the lab, because we're in a virtual reality team, we have access to like the HoloLens, the Vario XR3, which we use a lot as well, but is way more expensive, and maybe not that useful most of the time if you do interaction anyway. Yeah, we've been using headsets, but a lot of like spatial augmented reality as well, because it's really interesting for the audience. Like, so the scenography with headsets sometimes can be a bit difficult, and sometimes for the musician integrating with the other instruments. I know there are like literature on that, and with really interesting things, but we're trying to like cover different types of displays.
Okay, thanks.
Any other question? Yes.
Hi, yeah, it's an interesting talk. I was just curious where Godot is running on the headset itself. Is that something that you work towards, or is that something that Godot itself would do? And also, is it possible to do that with just free software, or does it need like a proprietary SDK or something like that?
That's a good point. So I mean, like the meta, it depends on the headset then, I guess, because different headsets have different systems. So for example, some headsets you can use the Monado framework, which is like a free open source implementation of runtime for OpenXR, and in which case it runs on a variety of devices. In our case, if it's a MetaQuest, then it's like a proprietary Android and Meta runtime for OpenXR. But then, I mean, Godot is like integrates OpenXR, so anything that uses this standard is accessible from Godot, which is, I think that's like, to me, Godot is a really good example of a really well-working free software community, like in terms of developing things. So most of the time they make the right choices. So, and like for the XR part, they actually made a really good one of like saying, okay, we're just going to use OpenXR from the start, which means that it takes, like it doesn't take any time at all to change from one headset to the other, from one display to the other. So that's quite, no, that's already in there.
And are you using the audio hardware also from the headsets?
Yeah. So for the embedded version using libpd, yeah, it goes. Well, actually, we're using the audio sound system for that. I'm trying to remember why. Yeah, because we were using RT audio, and like maybe there was something like an issue being able to run RT audio on Android. Maybe it doesn't work at all. Could be something like that. I can't remember. But yeah, for simplicity reasons, we chose to go through Godot for the audio rendering on the headset. But yeah, it uses the hardware, and they recently changed the audio subsystem to use the new Android audio subsystem, like Oboe or something, which is a lot better in terms of latency than what we had before. So it's not that bad. But when we need like really low latency to be able to interact with physical devices or apply effects to live input, then we switch to a laptop and jack. But in case of like an immersive installation where people walk around and or even trigger things, I mean it's fine.
A less technical question. I found some of the examples that you showed very musical and very nice. So do you see a compositional language developing around the environment that you're building?
That's a good point. So actually, yeah. So in most of the projects that we do, we're more in the like instrumental performance improvisation-based system, but that's interesting. I mean, there's a lot of work on composing in VR and in mixed reality. I mean, there could be some amount of that could be one of the like interaction techniques that could be developed. So new types of 3D sequencers and so on. So we haven't used that yet because most of the time we're interested in looking at the interaction and the gestures and the collaboration, and not so much the composition. But yeah, that's a good idea. Yeah, thank you.
There must be a lot of OSC traffic going back and forth between all the peers in this network of yours. Yeah. Did you run into any bottlenecks? Yeah, with regards to how much of the OSC you can send and receive, and maybe what have you used to overcome those limitations? Thank you.
Yeah, thank you for the question. So, not yet. Yeah, but it's true that we send a lot of messages back and forth. So, for example, there's usually a lot of visual feedback on what's happening on the audio side. So, like visualizing different types of audio features, loudness, envelopes, and so on. We try to reduce the quantity, like sort of like reduce the like the frame rates, or like not the sampling rate of what we send. Also, most of the time we do co-localized systems, so everything is on a local network, which makes it easier. We haven't used any of this for distributed instruments yet, which probably is why we haven't had any problems yet. Although for example, like on the immersive installation, like the quality of the Wi-Fi obviously is essential, but there's some ways to mitigate. So, for example, if it's visual feedback, if some packets don't arrive, it's fine because like the loudness is going to change over time, so it's probably okay. Godot for some of the interaction technique, so for some of the networking, for example, between the server and the clients, we use the Godot's integrated networking system, which uses eNet, which uses a reliable UDP. So if we want to make sure that something arrives between the client and the server, we add a server, and then the server communicates with PD, like on the same laptop or with a wired connection, which is really useful because if he was communicating using the mixed reality headsets to pure PD directly, we might run into some issues. Yeah.
Okay, so thank you again, Florent. So the next talk is by Eric von Kohler, and the title is Modular Ecosystem for Audiovisual Augmented Reality Performances.
Yeah. Hello, good morning. So we're not exactly doing the same thing, but at least we're staying with the same topic. So what I'm presenting is more a use case, I would say, and I call it a modular ecosystem, which is a fancy word for just I stitched together a couple of components. And I'm trying to make a point with this for why it makes sense to use Linux in this case, because it allows me to grab different components and create such an audiovisual augmented reality performance system. There's a couple of QR codes, so this would be, it's not that important. I think that's my site, and this would be our lab's website where you can read a little more. So let's go. So this all started, or like it's all centering around this actually fairly simple augmented reality interface, which is, we called the AR Cube when we started. We still call it that. And it's, the main idea is like to create hybrid musical performances. In this case, hybrid means we're combining augmented reality and we want to play it right next to reality. And so it's just like extending, and this is like an example from my perspective, playing modular and then having this, it's just a cube with a couple of, like, it's an XYZ controller basically. And this is like I've been doing this for a while, like whatever live electronics, modular stuff. And so we all tried XY pads, we all tried whatever hand tracking. And this is kind of actually what I always wanted in a way, but I didn't want the glasses. Why I'm doing this. So maybe I can give you like a short, let's see if this works. Actually I can show you the exact moment when I got the idea. I don't know if really. So this is one of these, I think it's the last quarantine session. So like this is Karma. It was for Karma's birthday there at this stage. And here on the left side, you see us in the like 2-month-old lab at Georgia Tech. And we were just doing this jack trip thing and streaming audio back and forth. And I was always playing with different cameras, like to make it slightly more interesting for people to watch this. And my student here, you see her, Luigi, she wanted, I don't have to, can't tell too many stories, I can tell a lot of stories, yeah. And she wanted to create like augmented reality stuff, and I wasn't like, totally not interested in these goggles, and I was like, but she bought them, and then we had this performance, and I asked one student to be like a camera person wearing this thing and like looking around, and then I wanted to stream that. And then was a little shy, and I was like, move, look at the devices, like, so, you know, like to create an interesting feed. And then here you see me, no, and then I stood up, and then I took those glasses like to maybe show what I'm doing to the, so that's, and so that means I basically only started with this because I wanted to give the online audience first-person perspective of what I'm doing. And in the end, that's one of the main aspects. So like, this is not only an interface, but it's also something that creates a much more interesting way to perform small electronic devices. So because sometimes, I mean, like for geeks, it's cool, like even like someone sitting on a laptop, but for a lot of audiences, it's not enough. So this is the Cube phase 1, and it's very simple. It's a 3 degrees of freedom XYZ controller. So, and I've been always thinking about like how you could do this with these, I don't know, strings, and like there's many ways since the 50s to do this, and this is like, but this is a very nice, clean way. It's coded in Unity. It tracks 4 objects and their relative positions inside this cube. So it's just like Cartesian coordinates, and it continuously streams their position via OSC to whatever. I will show that later. Yeah. So, but it just to an OSC listener, and so what we also do is like. We do research on usability and user experience with these devices, and here you see in our lab, so we would wear those glasses inside a immersive sound system, then basically control the spatialization and additional stuff. And we did a guided exploration, and that means we ask participants to perform specific tasks with it. And then we're doing qualitative analysis with a Think Aloud protocol, and that was presented at there's a conference for spatial user interaction where we did this. And if we look at 14, then you get an idea of how people would use this. So there's like instructions. And then we have a very simple, I found this old MIDI controller, and then people have like tasks, can control a soundscape, very simple generative stuff, and then we ask them, and we just ask them afterwards, or let them think aloud, and then we see like, okay, did this work or not? It kind of worked. So then the next phase is a little, and that's basically all I need, like it's a 6 degrees of freedom controller now, so that means we track still 4 objects and their relative position and orientation. So that's what you see here. That's why we now have indicators that show us how those small spheres or like objects are oriented in space. And then the rest is still the same. Like we're just sending now more data like per object. And then we did the next level. Like this. The next level UX experience is now that we asked like 12 different instruments to perform with this, and that's pretty bad because like many instruments they use both their hands, you know, like, and me as a modular, like I don't even need to do anything to play the instruments. For trombone players, it's different, and for, piano works pretty well, like the marimba, so, and actually this is I don't know, with all the time, she's probably going to present that today at 9, so my student is going to present that, and so here you see like one instrument where it's also tricky, like marimba with 4 mallets, and then always in between you want to adjust those little objects. But this is like, you see, we added curtains to our lab. So this is a marimba working with the instrument, with the interface in the lab, and then some more impressions like from a piano player. Maybe I can find a. So piano kind of works, right? Maybe if you use a synthesizer, makes it a little more like, so yeah, so this is a person controlling and playing at the same time. And what we did here is like, it was a lot of creative tasks, like create a small performance and then play it for us. So, and here's one of the more troubled, or like instruments which are more challenged, like playing the trumpet. I mean, it can be worse, like, you know, the hand is already there. So, yeah, 12 different instruments, and we found out that it's possible for some. Like, very short answer. And then what's more interesting, like in this context, like, or for here and now, is that while we went along with this research and development, we started performing with something we call 2 cubes. So that's Yung Kyung or Lu Hee Shin. Was my master's student, and now she just graduated, and she plays double bass, which is also not easy to use with this interface. And I play modular, and we've been touring with this like for me there was a lot of since last fall. So presented at a couple of venues. Here you see a picture from ICMC, which is not too long ago. And I can maybe show you a short video. And some ads first. And do I have... Thanks. Yeah. I don't know. Do you have the levels? Do you have hold of the levels? Because I want this to scream at us. Ah, okay. I mean, the recording now is like I recorded the ambisonic stream, but I didn't mix it in. So this is what they streamed. So it's a nice image quality, but I don't think the audio makes a lot of sense. Okay. Should get a professional YouTube account maybe if I use it for presentations. So here you see us play, but you see she found a way to play with this, right? So and I just need one hand. And so here you see, like, what you see here is like left side is me, right side is her, and this I don't think any of the videos. I don't think this video shows how, but it's a pretty big screen in our back, and you can also see her like when through my lens. Okay, so that's that. And here's the. Now we get to the technology, kind of, or like a little bit. So. Basically, there's like two domains which can run completely separated. They can run on 1 or 2 machines. I started with 2 machines. Then when I was traveling, I didn't want to take 2 computers, but I got X runs. So yeah. So basically, 2 machines is better. Should be possible with 1. So what we have here is like the audio part is pretty simple. Like we get audio inputs. It's going into Super Collider. Then I will explain later. This is not how it is anymore, but in a way it still is. So Super Collider does encoding, sends it with jack to a decoder like the IEM standalone, and then I output it to the loudspeakers. While the visual part is something more of a hack, like using ADB, screen copy, then the video for Linux and Pure Data and Gem. And this connection is kind of optional. So that means, but since I have Pure Data and Super Collider audio and visual domain, I can easily send over anything to manipulate the visuals, the camera feed. So the thing with the Quest is, I don't know, maybe some people know more. As far as I know, it's not really easy to stream it, right? You have to be in whatever metaverse, have the app running on whatever device. Like, it's complicated, and you need to, or you might need internet to establish the connection, but not afterwards. So as far as I know, using Meta's methods for streaming are horrible, or casting, or however you call it. So it's a no-go, and I couldn't process it afterwards or something. So the solution is this using ADB, V4L2, screen copy, and Gem. And this is like, I'm just going to go through this quickly, just a couple of steps to keep in mind. I mean, like, I think ADB runs on every Android device, right? So I think it's like a built-in feature, and you can access cameras, mics, and everything. You just have to activate whatever developer USB debugging mode, and then you will see on your machine that your device has a certain ID or unique identifier. Then with the V4L2, it's just that you load the module and you create as many virtual video devices as you want inputs. So in this case, with like 2 instruments, I'm actually working on a quartet, but more in my mind, not like we have 3 glasses now. But so like the idea is like to have a quartet with this. Yeah, let's see if that works. I don't know, USB bus, whatever, could be a problem. So in this case, I create 2 video devices, then later with screen copy, I can just get the ADB stuff and send it to this virtual device. And then in PD and Gem, I can simply get all these. I mean, like here you see, like I can get this. So video 10 is like the first quest, and video 11 is the second quest, and then I can just do all the shifting and scaling however I need it. So I would always get from one stream. I would always get. Oh no, it's not. Do I see it here? Yeah. So you've seen it in the other. So this is what you get from one quest. So it would always send left and right eye stitched together. So, which is actually not too bad. In the beginning, I tried to somehow seamlessly get one image out of it, but I dropped it and just take one side. But it's possible. So that's also how they create like one single image when they cast or stream it. So that, yeah, that's that. So with the audio part, I said like, so I'm basically doing all the audio processing in Super Collider. Super Collider also receives the OSC messages. It adds audio effects, does the encoding. In phase 1, it was strictly done with SCHOA. And then, as I said, like the IAM all-RAT decoder for HOA decoding, and I'm using AJ Snapshot to do the connection handling. So that means whenever I change something, I just patch it once. I'm getting pretty good at it. And then I just snapshot it, and this is a pretty good way, like running AJ Snapshot as a daemon, and then like whenever I reboot or like restart any part of the process, it's very reliable and works very nice. So this is how this looks like. Here, sometimes we use jacktrip to connect to our local machines. That's why I have it here. So inputs go into Super Collider, go and then encode it. Here in this case, I'm working with, it doesn't make sense. Yeah, I think it's 4th order ambisonics, and then into the decoder, and then into jacktrip. But this is what's written in the paper. But now I slightly changed it because traveling, don't having access to a mixing desk. That means I'm on stage, I get the microphone inputs directly, and I don't have and we had horrible feedback stuff and so going on, and so I needed some way to treat the audio signals. So now, and this looks bad, right? But it's but it's actually pretty good. And I thought it was a horrible idea, but I performed with this a couple of times now, and for me, all latency is nothing. I don't know. Maybe it's because I only do drones, and I don't. So, but this is fine. So what I'm doing now is still Super Collider does the OSC receiving, does the encoding. I'm working with different actually I don't know what's actually not ATK, SCHOA. I'm always when I change stuff, I might switch between those. And now I have everything else running in Reaper. I've always recorded with Reaper, but it was not part of the signal flow that was sent to the loudspeakers in the end. Yeah, so that means the inputs would go into Reaper, be processed, pre-processed, and then they go into the Super Collider rendering, and then they go back into Reaper for the decoding, and then they go to Jacktrip. And there's some additional paths, Jacktrip is, in this case, represents the loudspeaker output, okay? So, and I'm also have direct sense now. That means if I have one instrument that I want full on all loudspeakers, then I have some direct sense. Yeah, oh, it's clipping. So I don't want to go too deep into how the processing is working, but maybe the general philosophy. So here you just see yeah, how this is the ambisonics output out of Super Collider. So what we're working with here is a quad splitter principle. It's because I'm not at all interested in creating sound sources that are perceived to come from this and that location. There are several reasons. One of them is also if I have this control over, you could easily map the position of this sphere in the cube to a position of a sound source, in the room, right? So just imagine the cube represents the space we're in, and then I could move it, but playing, then moving, playing, moving, somehow you never get I think it's not satisfying, so I'm more aiming at this enveloping thing so that you get some spatial sound textures. So this would mean that where each of us would have 4 of these objects, and each of these objects would have one processing concept, granular feedback delay, something like that, and then we split everything into 4 sound sources, which are more or less always 90 degrees in azimuth apart. And all these different bubbles have slight variations in the parameter settings. And the parameters are then influenced by, for example, by the Euler angles, by the orientation of those objects. And that creates something that's more enveloping and not really not so much this location-based spatialization. Okay, this doesn't, I don't know how much sense this makes, inputs. It just shows how a few inputs get into a lot of HOA encoders to create this spatial sound scene. And yeah, just some over, so I'm using Reaper, the multi-channel stuff works good. It has been very stable so far. No issues, and maybe just some overview. I don't know if anybody from those is anybody here who develops those LSP? No idea. Okay, nobody. Okay, they work well. So I basically need to take care of feedback, for the bass and something. So that's why I added them. So this is what one input channel gets treated with, very simple stuff. And then for decoding, I use this, the IEM stuff, the HOA decoder, and some distance compensation for the loudspeakers. And I could do decoding inside Super Collider, but then I find tuning and changing stuff in the decoder, I find a GUI much more appealing. And yeah, and it's easy, so it's done a good job so far. Yeah, and then I don't know how interesting that is, but I'm using Tmux to get everything together. So I don't know if people use that for other stuff than developing. Yeah, maybe here, yes. Yeah, it helps a lot. So it's just I'm using like 4, 5, 6 tiles, have everything there, and even if something goes wrong in between, I have to reboot or whatever, it's pretty solid and very few embarrassing moments. I will play tomorrow, and I don't want to curse it. It's probably going to go wrong. Yeah, and that's pretty much it. So for issues, next steps, and so on. So I also want to try Godot. Like somehow I want to get rid of this meta. I want to get out of the metaverse. It's doing a good job so far, and it's like accessible. I don't have to like pay anything so far, as I know. And there's like lots of stuff to do on the interface. Then I don't know about like maybe there are discussions about Pipewire. For now, I'm always deactivating it when I'm on stage, and I'm activating it when I leave stage. So yeah, okay, because like it's cool at home, even for studio stuff I'm using it, like, but it messes up all my connection names and so on. Maybe someone can, yeah, it's happening, okay. Then with the visuals, try other tools, but the thing is really like Jam just worked, and I was looking for the fastest solution. And then there's like the benefit of modularity and the curse of modularity. Somehow the latest version of screen copy, I don't get the same results. So I have to, I don't know. Okay.
Okay, thank you very much. Thank you very much. So we have... We have time for a short question and a short answer, or maybe two, but okay. Robin?
Hey, thanks for the nice presentation. Have you considered splitting it up, having one performer and another person doing the spatialization live on stage?
Yes, we also did that. Like, I didn't include a picture here, but we had us playing with a third instrument, which was then connected to, yeah, yes, definitely. Also, like, and a couple of ideas on that. But
or
then,
walking around in the room.
But one of my path is always like to get rid of this conductor specialisateur thing, like, and to have like people treat the sound themselves. But yes, I have a couple of ideas.
Or walking around in the room, tracking position of persons. So you have also like.
There's so many things we can. Yeah. Okay, that was one short question, right?
And short answer. Thank you. Therefore, we have time for another short question and short answer. Okay. Okay, but
Yeah, thanks again for the presentation. Can you explain why did you use quad splitter for higher order ambisonics? Well, I didn't get it.
Okay, so it's basically, as I said, I'm not interested in, and it's also a matter of feasibility when I perform, and I think, or when people perform, so that, like, I want to create a spatial, kind of more like a spatial texture or coloring instead of having actual sound sources somewhere. Does it make sense? And that's why I'm taking a signal, I'm splitting it into 4 angles, and each of those angles, and they are slightly decorrelated by using different parameters in the process, and that creates like, and that's what I'm looking for, like that creates something like a spatial shift with the sound, but it doesn't make it like, oh no, it's there and there, and whew, but it's more like this feeling of envelopment and change in perspective. Let's see. But yes, and the thing is, like, also it's less error prone in terms of performance, because like having a direct like position control, it can be can sound very clumsy if you mess it up, and this one is it's safer in a way also when you're working with your instrument and that.
okay, thank you again, Henrik. So the next talk is by Albert Greff and Sophie Arends, and the title is, well, oh, it's a super complicated title. Algo Jungle Drums, Creating Rhythm from Jungling Patterns. Albert? Okay. Okay, sorry. Yeah, not that bad. Okay.
Okay, let me just do a quick sound check because we're experimental here. I have my
So yeah, thank you for this opportunity to present our project, Algo Juggle Drums. It is a new algorithm for translating juggling patterns into musical loops, which can be played back at a given tempo. How did this idea came along? I wrote my master thesis in the field of digital humanities and chose to do that at the computer music department led by Albert Greff at the Johannes Gutenberg University in Mainz, Germany, and we both wrote this paper for this conference. So this project was developed with a background of more specifically algorithmic rhythms. Authors to be mentioned here are Clarence Barlow, Gottfried Toussaint, or Georg Bönn. And by learning about these ideas to use mathematical models, the idea was to use the numeric juggling pattern notation called side swap to express with sequences of integers the values, the visual art of juggling tricks, but also the theoretical construction of them. And as known, rhythm in music also emerges from a measured succession of sound and time. Both so juggling and music, as you know, is characterized by repeating patterns with an underlying beat. And so this similarity we want to use for a new algorithmic rhythm. Side swap notation was invented from 3 different people independently around 1985. So this is not new to the juggling world. So the use of juggling movements as a control interface for electronic music has already been investigated in several prior projects. In contrast, our approach has the idea to enable control of a wide range of numeric sequences without necessarily requiring the patterns to be physically juggable. But what are these side swaps? The idea behind it is to keep track of the order that juggling objects are thrown and caught at a constant beat. When a ball is thrown, it stays in the air for a prescribed number of beats until it gets caught again. For those of you who already know and master side swaps, I can imagine that juggling is maybe familiar to some of you. We only look into vanilla side swaps for now. That means async non-multiplex side swaps, if you know about that. And for those of you who still have not such a good idea about side swaps, if you saw juggling before, you probably already saw a side swap, because even the normal cascade, like in the picture here of Burkhard-Polster, can be notated as a side swap. In talking about Burkhard-Polster, he wrote a book about math and side swaps, so for further reading, this is the book you should go to. So I tried to wrap it up with an example of 534. So for each throw, write down the number of throws that occur before that ball is thrown again. There are several different kinds of properties about side swaps. I just show like the basic ones. The average throw always gives also, it's always an integer if the side swap is valid. And it also is always the number of balls or objects you need to juggle the side swap. But this is not the only test for a valid side swap. You also can create the test sequence, and if all numbers in the test sequence are not the same, the side swap is valid. And in this example, the problem with 543 is that on the 6th beat, the ball, two thrown balls would come in down at the same time, the same hand. And that's not what we want for now. The name came along, side swap, to swap the landing sides of the balls thrown at two different beats. So this is a way to transform side swaps to related ones. Yeah. And now on the left side, you right hand side, you see this typical visualizations, and it's called space-time diagram. And for the jugglers, it's important also to distinguish between left and right hand. For us, it's not important, but yeah. But I hope you can understand with this diagram what I'm talking about. I can show you a quick video. This is a GIF generator from the project, open source project Juggling Lab, who generate all kinds of juggling patterns. That okay. And to show you a human being, because I'm not a stage juggler, so somebody else had to step in. The music, but yeah. So it's 54 is with some practice doable to juggle. So what we do then is analyzing the pattern in our algorithm. It takes a pattern, so a Lua table of non-negative integer values as input, and checks for all possible error conditions, and returns two Lua tables as a result. And The first table, the pet table, shows that it takes 9 beats to run through the pattern 534 with all needed objects, and the table gives us a pair on each beat with object number and throw height, which we will use then for the mapping. The other table shows us the cycle of throws each individual object goes through while running through one cycle of the juggling sequence. And so here the space-time diagram also can be notated as a necklace notation, so a time circle, which is orientated of these necklace notation for rhythms that also, for example, Gottfried Toussaint uses a lot for his geometry and rhythm analysis. Turning side swap patterns into music. So the mapping objects to MIDI note numbers and the throws to velocity is giving us a single MIDI note to play for each beat. So you can see that we have two different rows or circles. The throws have their own order, and the objects too. And actually, you can also divide side swap patterns into orbits. So you have, in this case, 504 orbit with 3 balls and 030 orbit with 1 ball. So in this case, the second object always has a throw height 3. So there, the MIDI note number velocity is always the same, and for the other objects, it shifts. So this is our PD patch. It's a simplified version. So you see in the middle is the AlgoJuggle Lua object, and there you can do some swaps. The metro goes on the left inlet, on the right inlet. You put in some presets. For a short demonstration, Albert prepared a bigger setup, an ensemble patch with 2 AlgoJuggle sub-patches, which have been set up so that they listen on different MIDI channels, 1 and 10. This comes along with real-time MIDI control, and we are using here the Novation Launchpad Pro. So I will show this now quickly. I also can. So this is 534. We also can switch to other side swaps. 441. MIDI channel 1. Let's start this. maybe that's maybe enough. So to get to the conclusion, the method can be used to supply ideas for compositional purposes already, and is a good tool for live performance if you set it up with MIDI control. And so if you prepare a collection of interesting sideswap patterns. The problem is still that it can be hard to control the kind of musical sequences. And the other thing is our implementation currently doesn't include a sideswap pattern generator. So there already exists a pattern generator that is this Juggling Lab project of Jack Boyce and many others that creates, based on a state graph idea, all patterns that are possible. But we need still more a filter that gives us musical interesting patterns. So we want also to pitch like our question, is it possible to characterize the musical properties of sequences generated from sideswap patterns in a way that makes it easier to specifically design such patterns for musical purposes? So we need to think about maybe to analyze about the lengths, the pulse lengths or the beat lengths of a pattern, and also the and other properties that make the pattern musically interesting. And then we can have a preloaded database to attach to that idea. So thank you very much.
Thank you, Sophia. It's and Albert. Very interesting idea. Do we have any question? So we have time for long questions and long answers. Not that much, but.
Thanks, Sophia. I was wondering, maybe I didn't get it, but you speak about live performances. Is there some link between a real juggler being filmed by a camera detecting the position of the boards and then converting that in real time into patterns, or are the patterns pre-stored in your setup?
Yeah, so for us, I mean, this exists in other projects that you also can film it and use this data. For our project, we have a preset and we load it to it. So the idea is to use this pattern. We actually can look for patterns that are not juggable, to have actually a wide range of different patterns to be used, and also when we played around with it, the thing is sometimes musically interesting patterns that are not looking that good being juggled. So yes, so basically we want to use mainly this idea of this construction of these numeric patterns.
Thank you. Do we have? So I have a question, Robin. Sorry. How difficult would it be to generate the pattern, having some knobs to generate them? You don't know. Okay, thank you. It's an open question. Is it open? It's a mathematically open question?
Could be NP hard or something. You still need to formulate the problem.
Okay.
So the thing is, you have to start somewhere with these ideas, and there's a way to enumerate these patterns on this state graph that Sophia mentioned, but there's no obvious algorithm to pick out patterns according to certain musical criteria. So that might well be an NP-hard problem.
Okay, thank you.
Number theory involved as well. So.
Okay. So. Okay.
Two short questions. The first one is, could you play for us a very simple 3-ball juggling pattern? Because I had trouble in my mind following from your theoretical explanations to what we were listening to. Like, do you have like the most simple 3-ball juggling pattern that you could play for us now? Or 4, whatever, like, just so it becomes easy to actually understand. And my second question that comes directly from that, do you think it would be helpful for jugglers to use this oralization to learn and deal with juggling patterns? Like, is there like a nice mental connection from hearing it to actually being able to practice it?
So to the first question, like the most simple sides would be 3, the 3-ball cascade, but that would be just like a constant beat. Like there would be no different velocities or something like that. And in juggling, so the thing is, this is also with the live performances. If a juggler juggles it not clean or maybe also on purpose, you can get into a galloping rhythm, for example. Which is when you just base it on these patterns, like the numbers, you always have this clean distance between beats. And the 5-3-4 pattern, like I can maybe show it again, will be just have this different velocities if you just play it on one drum section. So if you there you can hear the 3 different velocities, and we leave out the mapping with the different 4 objects. And if I add like 4 objects, so this is getting pretty quickly, not so easy to actually follow in mind, for sure, yeah. And your second question, if a juggler can learn with it, maybe with this first version that you just hear the different velocities, because as you also have to give the different impulse to throw these balls. So that for the juggler, that is the interesting thing about side drops, to give these different heights of throws, and your mind is like going a bit crazy in the beginning, and then
Thank you. Do we have another? Yeah, okay.
So when you juggle and you switch between patterns, and there are patterns that are similar to each other, are they also musically similar, so that you can do the same sequences as a juggler, and then you get a similar sequence in the music?
Yeah, basically yes. well, is a side swap of 534. So a swap would be, for example, 441 or 444. So you can also make, by swapping, also make the pattern easier and then switch into the more complex one. And that will be, of course, also in the musical version would be the same. Yeah.
France?
Not a question, just about the mathematics of patterns like the ones we are discussing. A good reference would be Donald Knuth's Art of Computer Programming, Volume 4. It's all about this sort of thing. That's just if you want to study the maths and the algorithms that exist.
Okay, thank you. All right.
Any other question? Okay, so thank you again.
Thank you, Jan, and to the speakers for this very nice session. So we're going to have a coffee break now. You can go upstairs, get your coffee, maybe come back here if you want to be in a slightly colder room. Just one detail. Those of you who have demos this afternoon, could you come talk to me? Because we were going to do them upstairs in another room next to the coffee room, but it's very, very hot there. So I think maybe what we can do is actually do them here, at some point this afternoon, because there is air conditioning and it's nicer. So yeah, please come to me so that we can see like what your technical requirements are to make this happen. Thank you, and yeah, we'll resume in 30 minutes.